Welcome to our class, everyone. So today we will talk about memory hierarchy. So what's a memory hierarchy? Why we need this? So let's start. So we know there's a three abstraction for your operating systems, your Linux kernel, which is process, which is virtual memory, which is files. So we already finished, we already covered the files in other videos. Today, let's talk about virtual memory. But before we talk about the virtual memory, let's talk about what the memory is. What's the difference between virtual memory and the actual memory? Okay, so actually, there's a very specific memory hierarchies here. There's a layers, like in different layers of a memory level, there's a different device to support your memory. So let's start with this example. We know this is 230, so actually this course. For this 230, we have two instructors to support this, Peter and I. We try to support this 230, right? And we have like a couple TAs to support us. Actually, we have 4 TAs, and we have AUCAs to support us. Okay, so this is kind of a level of the structures we like support this class. If, for example, we miss the data for this 230, we miss one grade for this 230, Peter and I need to find out how to get the data to support the 230, right? So we try to support the 230. If we cannot find the data, we will say, okay, TA, Shuhenshu, could you like get me this data to me? Or we can say, Qingyang, could you save the data to me? Maybe the data is in there. So they try to support us as a TA. And of course, there's another UCA to support this course too. So if TA, they cannot find the data, they will ask a UCA to support the data. So actually, the structure is very similar to our memory hierarchy systems. So you can imagine that we have a label, the top label, which is called register. Then the second label, we call it cache. Cache is cache, okay? So we call it cache. And the third label, which is RAM, your memory. Actually, a lot of time we say memory, we say RAM, physical memory, okay? Then the last part is hard disk. So we try to load the data from disk to RAM to cache to registers. Then we can use the data set in our registers to compute for the result we want to compute. So this is kind of a hierarchies we have for this course in 230, actually for this machine. So inside the machine, actually there's a different level of your memory device to support the data, to support your memory. And in memory hierarchies, you will find that the top one is very fast because there's only few of registers in your computer. So this part is very faster. This part is slower. So it looks like this. So the cache is faster than the RAM, your memory. The memory, your physical memory, is faster than your disk. So actually, the disk is your virtual memory, but I'm not going to talk about this today. This is your virtual memory, but yes, the RAM is faster than disk. Cache is faster than RAM. Of course, the register is faster than cache, but because they are faster, so definitely it's hard. It's very hard to define, like decide how to do it. So in this case, you will find that this one is cheaper, this one is expensive as a money. If you want to get, for example, 4 gigabytes RAM, it's definitely is more expensive than you just want to get like 4 gigabyte hard disk, right? The hard disk is usually like a 1 terabyte, 2 terabyte, not 4 gigabytes. So you can see for each like a byte of memory, the top one is more expensive. The register is expensive than the cache, than the RAM, than disk. Okay, so this is kind of the basic idea of the memory hierarchy. Because the register is more expensive and the cache is also expensive. So we will see like we have fewer registers, fewer cache compared to your RAM and your disk. So in this case, if we have a lot of data here, we cannot definitely like load every data into the register because there's so many data on your disk. We cannot like load every data to your register, right? So in this case, actually there's a like a very complicated like a cache miss and cache hit like a strategy to maintain this. Okay, so even for the cache, we can have a different level of cache: L1 cache, L2 cache, L3 cache. So there's a different level of each cache, and usually L2 cache is larger than L1. Okay, because we want to store more data in L2 compared to L1. L1 is more expensive. L2 is like a not so expensive, but still expensive, more expensive than memory. Okay, so if we want to use the memory hierarchy, what should we do? Just keep in mind, every data need to be passed to a register. Without register, we cannot use any data to compute the result. Okay, so if you want to like you want to like compute A plus B, you need to load A and B to register, compute it, then store back to the memory. So this is really important concept. Okay, so right now if we got the register A, we want to get the A, and register say, okay, I want to get A, and we find A is in the L1 cache. In this case, we can easily access to this L1 cache back to register and copy A to here, right? So it's very fast. So the time you only need is for just this like a force and back. It's very quick, very quick. Maybe it's just like one cycle. Okay, but if for example if we want to get B, but let's not be here. B is in our maybe memory, not disk. This is worse, terrible, but maybe it's in our memory. So in this case, the register will say, okay, L1 cache, I want to get my the B, but L1 cache cannot find it. Oh, let's not B here. I should talk to L2 cache. And L2 cache say, no, I don't have B here. So it's talk to memory. So in this case, memory return B to L2 cache, return B to L1 cache, return to register. And you can see it's like a long pass, right? So in this case, you will lose a lot of time, maybe like a 100 cycles, 1,000 cycles. Okay, so you will got a lot of cycles here because you need to pass pass this information and try to load data into like a up. You try to like go through like each level of this memory hierarchy. Okay, so when we get the data, we call it heat. If we did not see the data, we call it miss. So this is miss, and this is heat because we got data inside the memory. So this is heat, miss, heat, and this one is heat. That's it. So we call cache hit means we want to access the data in the cache, and the data is already in the cache. So this is a cache hit. If we want to find data in the cache, but there's no this data in the cache, we call it miss. So this is a cache miss. This is a cache miss. And for the memory, because the data is in the memory, so it's a hit. It's not a cache hit, it's a memory hit. Okay, so this is the difference between hit and miss in a memory hierarchy. And you can see if you have a lot of miss, you will need to you will need to spend a lot of time to like pass these data back to the registers. Because of this miss and hit stuff, we usually have a formula, we have an equation to compute how efficient your data, how efficient your memory systems for your program. If for this program, when you run it, how long you need. Okay, we can use the cache miss, cache hit to compute. For example, if each memory hit is one cycle, okay? If each memory hit is one cycle, and maybe the miss is like 100 cycle. In this case, you can see the average of this hit and miss is 1 plus something times 100, right? So let me clear it. So this is the formula. 1, because every time we want to hit, if we hit, no matter you hit or miss, you definitely, your register need to go to the cache. So the 1 is always be there. Then if it's miss, you need another extra time here, and which is 100 cycle. And 100 cycle times how many percentage you miss. Okay, how many percentage you miss. So actually here we can get something called miss rate. If I try 10 instructions, I miss 5 of it, which means for these 5 instructions, I need to use like 100 cycles, extra 100 cycles for these 5, right? So in average, I need to get like if this is 50%, it will be 1 plus 100 times 50%, it will be 51. So in average, each instructions you have need 51 cycles to do it, because you use 5 cycle to deal with 5 instruction, but you use another 505 cycle to deal with another 5. So in average, it's a 51 for each instructions. And in total, is not, definitely it's not 51. It's like a 51 times like how many instructions you have, 10. So you got like a 510 cycles. Okay, so this is how you compute the average access time. Okay, so average access time equal hit time. If it's hit, how much time I need? Because you still need to load the data from cache to register, right? So hit time plus miss time, miss penalty, okay, miss penalty, because this is the actual one, extra cycles you need for the miss. Then times miss rate. So this is the actual penalty. Okay, so in the end, you can get this equation. Average access time equal to hit time plus miss penalty times miss rate. So if your hit time is 1, your miss penalty is 100, and your miss rate is 10%. Just for every 10 instruction, you only miss 1. In this case, the average access time still 1 plus 100 times 10%, which is 11. So for each instruction, you need 11 cycles to complete. It's still huge, right? It's still huge. Compared to if you don't have any miss. If you don't have any miss, you only need 1 cycle for each instruction. But with 10%, you need 11 cycles for each instruction. It's even 11 times. Okay, so a lot of researcher or like a programmer, they try to minimize this cache miss because they want to improve the performance. If you can reduce the number of miss in your program, your code will be much faster, like a couple times faster than the original code. So this is like a skill or a technique to optimize your code. Okay. So this lecture for today's video, we cover the memory hierarchy. Actually, there's a different level of the memory device in your computer. We use the cache to support register, and we have a memory, and we have a disk. So if we cannot find the data on the cache, we will like go down, try to find the data in the memory. If the memory has no data, it will try to go down again to see the disk. And you can see because it's larger, the device is larger and have more data, so it's getting slower. So if you really want to get the data from disk, it will slow down a lot of your program. So we cover what's a hit, what's a miss, and how to compute the average access time by using the miss rate. and hit time and hit the mismatch penalty. Okay, so I hope you enjoyed today's lecture, today's video. See you next time. The memory hierarchy is